Welcome to this video on refraction through lens, where we're going to see ray diagrams and image formation, and this is just an introduction. So for understanding ray diagrams and image formation, we're going to study convex lens with object at infinity. So let's see how an image is formed when object is at infinity. You can see the image formed by a convex lens on the wall, and this image is caused due to an object at infinity, and in which case it's all the plants and the screen and all those stuff which is coming from, light from those are coming from very far away. So that's what we consider as infinity. So light from there comes and falls on this lens, and you can see that an image is formed on the wall. And the distance between the lens and the screen is a focal length. And what you can also see is you can see that the image is highly diminished, and it's all inverted. You can see those screens are all inverted, and you can tell that that's an inverted image. And let's look at the screen again. Yep, that's a screen, and here you see. Now you may ask how to exactly get this image. So the way to get this image is you hold the scale and you hold this lens and you position it a little forward so the image becomes blurred, and then position it a little backward so the image gets blurred again. And you know that the focal length is somewhere in the middle. Then you position the lens somewhere in the middle so you get quite a decent image in the wall. Okay, so there you go. That's the right position, and then you can read what is the value at which you have kept the lens, and here it is 10 centimeter mark. So the focal length of this lens is 10 centimeters. In the demonstration that we just saw now, this is our screen, and this is our lens, and this distance that we are seeing is what we call as the image distance. So that's V, or image distance. And from the lens to the far away objects, the distance that's there is what we call as U, which is the object distance. And usually the object distance on the left of the optical center is we consider it negative. Let's say in this case the screen is probably at about 10 meters, so we say minus 10 meters or minus 1000 centimeters because it's on the left of the optical center. And the image distance, which is on the right, is positive because it's on the right of the optical center. So let's look at the image formation of how this image is formed of a distant object. So here is a representative tree and a lens and the screen where the image was formed, and this focal length of this lens is 10 centimeters. So the tree is at about minus 1000 centimeters, so the left, as we discussed, and this is far greater than f. That's about 100 times greater than focal length. The rays from the far away leaf, since it's so far away, they literally come parallel to the lens and they form an image on the screen. And this is all the leaves, they come in as parallel rays and they form a small image in the screen. And similarly, the bottom part of the tree, rays from there come and they form an image on the screen. And rays from the center also form an image in the screen, right? So together, all these rays, they form an inverted image, which is diminished and real and inverted. Diminished because it's small, and real and inverted as it's captured in the screen. So the image distance here in this particular case is 10 centimeters, and it's at the right of the optical center. And the plane at which this image is formed is called the focal plane. The height of the image object can be represented as O, and height of the image is represented as I. In the demo that we have seen just now, we can predict where the image will be formed by using what we call as a lens formulae. So let's try to apply and find where the image will be. So in this case, U was equal to minus 1000 centimeters and F was given as 10 centimeters. And the reason why we have minus here is because anything on the left of optical center is negative. So let's substitute it in this equation of lens formulae, which is 1 by V minus 1 by minus 1000 equal to 1 by 10. So this will be 1 by V, minus of minus is plus, 0.001 equal to 0.1, or in other words, 1 by V would be equal to 0.1 minus 0.001, that will be equal to 0.0999. So that's what we have. So let's find out what V will be. So V will be 1 by 0.099, that will be 1 divided by 0.099, that's equal to 10.10. So that's 10.10 centimeters. Now this is very, very close to our F, because our F was approximately 10 centimeters. The F was actually equal to 10 centimeters, right? And the V is very close to F. Now let's assume what would have happened if U was infinity. So U was minus infinity. That is to say, this distance was very, very far away. Now let's substitute in the equation. You would get 1 by V minus 1 by minus infinity is equal to 1 by 10. Now this quantity will be 0, so your V will be equal to 10 centimeters. Now you can see that between this and between this there is not much of a difference. So in general we say that when U is really, really greater than F, so in this case this is U is about 100 times the distance of focal length, then your V is approximately equal to the focal length. So that's what we have said here. The V is equal to, but we should have accurately written as V is approximately equal to a focal length. So in summary, for large distances we can as well write we can as well write U is minus infinity. When we say large distance, we imply that U is far greater than F. So we can as well write U is infinity, and we can write V is approximately equal to F. Now let's understand the idea behind magnification. So the magnification M is given by the image height divided by the object height, and it is equal to your V by U. So in this particular case, our magnification is equal to V is 10.1 divided by U is, let's say it is minus 1000. This quantity will be approximately equal to minus 0.001, which means that our image will be equal to minus 0.01 times the object. Now we usually say that this is approximately equal to 0. The magnification is 0, or the image is the size of the image is approximately 0. Oh, wait a minute. So why did I say the image is minus 0.01? Actually it's, I said minus 0.01 the size of object. What this means is if your object is 5 meters, your image size will be minus 0.01 into 500 centimeters. That's minus, or rather, let's say, into meters. Let's keep in meters. 0.05 meters, right? So this is minus 0.05 meters, or in approximately we can say this is 0 when you compare it with the size of the object. So that's why we say these images are highly diminished, and also it is real / inverted. So these are key terminologies for your type of image. So here's the summary. When your object is really far away compared to the focal length, we say object is at infinity and you have almost zero magnification, which means that your image will be very small. Now physics is all about approximation. So for simplifying this whole ray diagram, we don't draw this whole ray diagram conventionally. We just draw these rays to represent that how the image will be formed when the object is very far away. So usually you will see what we do is we draw a straight line, and this is our principal axis, and you draw the lens. I'm drawing a freehand drawing. It'd be good for you to use your scale. Mark your approximate F, maybe 5 centimeters or maybe 3 centimeters, and 2F, which is 6 centimeters, or you can mark any arbitrary points to represent an object, ray from an object coming from infinity. We just draw the central ray. In this case, this orange ray. So let me also mark this by orange. So this is our orange ray, and that converges at the focus. So what we do is we greatly simplify our ray drawings by just drawing this one ray from the center. So let's look at our learning objectives. So we did look at convex lens. We saw how the image is formed at infinity. We understood what happens through the ray diagram. We drew the simplified ray diagram. We understood how to use lens formulae and magnification, and also how to apply the sign convention. Anything on left of optical center was negative. And finally, we applied these and understood what we mean by infinity. I would urge you to recreate the narrative of all that we have talked and try to reproduce it in your notebook. And in case you find any difficulty, please watch this video again. See you until the next one. Ciao.